here's how to write recursive sequences. So right over here, this is our sequence. And you might just immediately notice that this is an arithmetic sequence where the common difference is 1. So to get from one term to the next, we're just going to add 1. Now you might know how to write this sequence in this arithmetic explicit form. So let me just write this down. So the explicit form of an arithmetic sequence is going to be a sub n is going to be equal to a sub 1 plus n minus 1 times the common difference. So in this case, right, a sub n is going to be equal to a sub 1, aka our first term, so our first term is 1, plus n minus 1 times the common difference. So our common difference in this case is just going to be 1, right? That's our common difference. And this is how you write the sequence explicitly. Now, writing sequences recursively is a little bit different. So the first step you're going to do is you're going to write out the first term. So our first term in this case is going to be equal to 1. And then the second step is going to be to write the equation in terms of a sub n minus 1. What do I mean by that? So in this case, what I'm going to do is I'm going to say, okay, a sub n is going to be equal to a sub n minus 1. And a sub n minus 1 represents the previous term. All right. So if a sub n is the nth term, then a sub n minus 1 is just going to be that term before the n. So for example, if let's say we have a sub 5, right, then the term before that is going to be a sub 4. So this can be denoted as like a sub n, and then this one would be, a sub n minus 1. But this is all just to show you that, a sub n minus 1 is just the term that's before a sub n. All right. Now, what are we doing? So if this represents the previous term, what are we doing to the previous term to get to our term here? Well, we're just going to add 1 to our previous term, right? All this is saying is that, well, in order to get to a certain term, well, you're just going to take the term before that term and add 1 to it. So for example, if I want to get to a sub 5, well, what I'm going to do is I'm just going to take the term before a sub 5, so in this case a sub 4, and I'm just going to add 1 to it. And yeah, that's how you write it recursively. So you just have to write it in terms of the previous term, right? What do you have to do from the previous term to get to the next term? That's what you should be thinking. So let's do another example. Let's say if we have 1, 2, 4, 8, 16. This right over here is a geometric sequence. And if you want to write this geometric sequence explicitly, the formula for this is a sub n is going to be equal to a sub 1 times r to the n minus 1 power. So this is for a geometric sequence. And in this case, notice how this geometric sequence has a common ratio of 2. So you get from one term to the next term, you're just going to have to multiply by 2. Now, if I wanted to write this explicitly, this would be just a sub n is going to be equal to a sub 1, aka the first term, times the common ratio, which in this case is 2, to the n minus 1 power. And there we have it. And the reason why this is called an explicit form is because, well, you can find out, let's say if I wanted to find out what a sub 42 is for this sequence, well, all I have to do is just plug in 42 in for n, right? I just plug in 42 in for n. So in this case, it would just be 1 times 2 to the 42nd minus 1. And you can get the answer this way. But for a recursive sequence, there is no shortcuts to this. But in a recursive sequence, there is no shortcut for this, right? Notice for this recursive sequence right here. If I want to know, let's say, the 49th term of this sequence, well, if I was using this, so for example, if we go back to the example before, right? If I was using this sequence right over here, this recursive sequence to find the 49th term, if I wanted to find the 49th term, well, I would have to know the 48th term, right? Because it's in our formula, right? If I wanted to know the 49th term, I would have to know the term before it, aka the 48th term, to get that. And if I wanted to know the 48th term, I would need to know the 47th term, and then the 46th term, and so on. So with recursive sequences, there is no shortcut. Now, here's what we're going to do. Once again, we're first going to list out what our first term is. So our first term, a sub 1, is going to be equal to 1. And then for our second part, what I'm going to write down first is a sub n equals a sub n minus 1. And then let's just stop here and think about it, okay? Now, a sub n is the nth term. And then a sub n minus 1, remember, that's the term behind the nth term. So what do I need to do to get from the term behind the nth term to the nth term? In other words, let's say if I wanted to get to 16, well, what do I have to do to the term before it to get to 16, right? So what do I have to do to the term before the nth term to get to the nth term, right? And in this case, what we're just going to do is just going to multiply our previous term by 2, right? In order to get to the nth term, what I do is I take my previous term and I multiply it by 2. So in this case, our recursive formula is just going to be a sub 1 is equal to 1, and then a sub n is equal to 2 times the previous term. And you can write this out as well. If we wanted to check our answer, well, if I wanted to find what a sub 2 is equal to, I can do a sub 2 is equal to 2 times a sub 2 minus 1. If you're wondering where I got this 2 from, well, notice how there's an n here and an n here. So if I substitute 2 in for n, I have to substitute 2 in for n here, right? I have to sub 2 in for both of them. So I'll just get a sub 2 is equal to 2 times a sub 2 minus 1, or just a sub 1 itself. And we know a sub 1 is equal to 1, so we can just substitute that 1 in. All right, this is why having the first term is very important, because if I did not know what a sub 1 is equal to, well then, I couldn't find out what the second term is equal to. And I could just repeat this process. If I want to know what a sub 3 is equal to, it's just going to be 2 times a sub, and then in this case, our n is 3 minus 1, right? Notice how the things match, right? So 3 minus 1 is just going to be equal to 2, and then 2 times, in this case, we know a sub 2 is 2, right? So now we can substitute that here, and then just get a sub, so just 2 times 2, and then 4. And then notice this pattern, right? So we have a sub 1 is equal to 1, a sub 2 is equal to 2, and then a sub 3 is equal to 4, and then we can just do this on forever, right? Notice how it matches what we had originally. So here's just like a little quick example. I'll show y'all how to do it, and then I'll give you some practice problems to work on. So let's say if we have this sequence and we want to write it in a recursive sequence format. So remember, your first step is going to be to write out what a sub 1 is. So in this case, let me just write. So first step is to write out what a sub 1 is. And in this case, my first term is just going to be equal to 1. Now, I want you to identify a pattern in this. So what's the pattern in this sequence? It might be a little hard to find out at first. Well, the pattern is that what we're doing is we're multiplying by 2 and then adding by 2. Okay? So that is the pattern of this, right? We're going to take this term in this case. So 1, we're multiplying it by 2. So 1 times 2 is 2. And we're adding 2 to it. So 2 plus 2 is 4, right? To get from 4 to 10, well, 4 times 2 is 8. And 8 plus 2 is 10. So to get from one term to the next term, so let me just actually write it down. So if we want to find a specific term in a sequence, well, what we're going to do is we're going to take the previous term, we're going to multiply this by 2, and we're going to add 2 to it. And then that's just going to be our answer. So the first step is just writing out the first term itself. And then the second step is just identify the pattern in it, and then just kind of like, then you can kind of substitute that in, right? You just identify the pattern, times 2 plus 2, times 2 plus 2, right? And that's exactly what you're doing with the previous term to get to the next term. And, once again, I'll just check the answer to, make sure I have it correct. So if a sub 1 is equal to 1, then a sub 2 is going to be equal to 2 times a sub 2 minus 1, just a sub 1, and then plus 2. If we know a sub 1 is 1, 2 times 1 is 2, 2 plus 2 is 4. So that checks out. If I want a sub 3, this is going to be equal to 2 times a sub 2 plus 2. A sub 2 is 4, right? We said how that's equal to 4. So 2 times 4 is 8. 8 plus 2 is 10. And yeah, that seems to match up. All right. So now I have these 3 sequences. Feel free to try them. The third one is a challenge one. All right. So for the first one, this is looking very... So for the first one, this is looking pretty similar to our first sequence we saw, where it was 1, 2, 4, 8, right? Where our common ratio, the number that we have to multiply by to get from one term to the next, is 2. But in this case, notice how there's a pattern. It goes from positive to negative to positive to negative. And whenever things change signs like this, you're going to be multiplying by some negative number. Think about it. Negative times positive gives you negative. Negative times negative gives you positive back again. It's the only way that this can happen. So we know that the number we're multiplying by has to be negative. And in this case, it looks like the number is negative 2, because 1 times negative 2 gives me negative 2. -2 times -2 gives me +4, and so on. So I can write this in a recursive sequence formula. I can say that my first term is equal to 1, and I could say that in order to get to a certain term, what I do is I take the term before it, and then I multiply it by -2. Or you can put the -2 in the front, doesn't matter, but this is how you do it. For the next problem, it's kind of the same thing, right? We're multiplying our thing by 3 every time, right? So we're just going to say that our first term is equal to 3, and then a sub n. In order to get to the nth term, what we do is we take the term before it, and we multiply it by 3. Now for the last one, this is a little bit of a challenge problem. Is there any trends in this? Well, it can't be I multiply by 3, because 6 times 3 gives me 18, not 14, right? So we know this can't be correct. Okay, well, let me see. If I add 4 to this, okay, then I add 8 to this to get to 14. Then I have to add 12 to this. Wait, what the hell? These are multiples of 4. These are multiples of 4. But how do I make this into a recursive sequence? Well, first of all, the easiest step is just to make the first term, right? We write down our first term. But then what do we do? Well, look at this. All right, so we know that every time that we go from one term to the next, we're going to be constantly adding our common difference by 4, right? In order to get from one common difference to the next common difference, we add by 4, right? So in other words, like the differences of our common difference is going to be 4, which means I can say, okay, if I want to get to the nth term of my sequence, what I'm going to do, first of all, is I'm going to add 4 to it. But because this 4 keeps on increasing, right, it's multiples of 4. And then what we're going to do is we're going to put an n minus 1 here. Now, this might seem very confusing at first, but let's look at it like this. Let's check our work to see if this is correct. So we're going to have a sub n is, in this case, if we want to find out the second term, a sub 2, we're going to get a sub 1, right? If we plug in the 2 here, we're just going to get a sub 2 minus 1, which is just 1, and plus 4 times 2 minus 1, right? Because if we're trying to find a sub 2, then this n right over here also turns into 2. So we just get a sub 1 plus 4. All right, and we know a sub 1 is 2, so 2 plus 4 is just 6. Now notice what happens if I plug in a sub 3. A sub 3 is going to be equal to, in this case, what we do is we take the previous term, so a sub 2, and then this is going to be plus 4 times, in this case, 3 minus 1, so 3 minus 1 is 2, and then we get a sub 2 plus 8, right? So in this case, our second term is 6, so 6 plus 8 gives me 14. So now you notice how this n minus 1 is important, because what this does is as n constantly increases, so as n goes from 1 to 2 to 3, our common difference gets bigger and bigger, and it's getting bigger in multiples of 4. This 4 is sort of telling us how much is our common difference changing as our terms get bigger and bigger. And this is just telling us that as our terms get bigger and bigger, our common difference is just going to be added, to 4. It's just going to be 4 added every single time. Okay? So this is going to be the answer to our problem.